Two coins on the same rotating turntable. Coin A is 10 centimeters from the center, and coin B is 20 centimeters from the center. Which coin has the fastest speed? V. Why? All right, so as these start going around, remember what V is. V is your distance over time, right? Or your displacement over time. So your displacement over time, your linear displacement over time. If you go around exactly one time, then we call that the period. And your displacement on a circle, how far do you travel in one revolution? You travel the circumference, 2 pi r. So which one has the greater speed? To look at that, they'll both have the same period because it's going to take the same amount of time for these two to rotate and make a complete circle. So if the time is the same, the only other thing that can change is the radius. So what happens if you make r bigger? R is in the numerator, so that's going to make v bigger. So B has the fastest speed because it travels a greater distance in the same amount of time. In same t. Okay? Shocking? I hope not too shocking. What about the angular speed? Omega, angle per time. So omega is angle, change in angle per time. Okay. It's also V over R, right? And I think if you look at it this way, it's a little bit easier to see. So our angular displacement is, our angular velocity is how fast we move through a set angle. It's also our linear velocity bent over the radius. So which one's bigger? Well, let's see. For A, sorry about that, pre-circled yellow. I made a mistake. Misspoke. So omega equals V over R. For A, we have a small v and a small r. Meanwhile, for B, omega is this size. We have a big v and a big r. Well, because both the velocity and the radius are small for A, we get a certain omega. It turns out that because we have a bigger velocity and a bigger radius, that both of these are going to have the same angular speed. So omega is the same. Another way to look at it, if you want to go even further with this equation, V we said was 2 pi r over t, so we have 2 pi r over t over r. Big fraction on top, so all of this is going to condense down, and it's going to end up being t times r in the denominator. Radius doesn't matter. If we look at 2 pi over t, it's going to take the same amount of time for A to make a complete circle as it is for B to make a complete circle. So that means omega is the same. And we can use that in our definition because t is same. They're both going to travel through the same amount of angles in the same amount of time, is another way to say that.